Hello guys, welcome back to the course. In this video, we are going to start the second project, monitoring air quality. Let's read the problem. Air pollution poses many challenges, presenting not only immediate health risks but also long-term environmental consequences. The detrimental effects of air pollutants on human health, including respiratory illness, cardiovascular disease, and increased mortality rates, highlight the urgent need for a comprehensive monitoring and analysis initiative. So in the second project, we are going to monitor air quality index in Los Angeles. In addition to that, we are also going to display the air quality index for its locations in Los Angeles, so you will be able to see which locations has good air quality and which locations has bad air quality. Okay, so now let's get started. Let's go to Google Colab. The first thing that you need to do is to install Folium. So let's copy this and let's compile the code. As you guys can see, we have successfully installed Folium. Next, we are going to import several Python libraries. The first one is Folium. Next, we are going to import heatmap from Folium plugins. We are going to use the heatmap to visualize the air quality index. Next, we are going to import pandas. Next, we are going to import NumPy. And lastly, we are going to import Google Colab files. We are going to use this library for uploading the datasets to Google Colab. Okay, so now let's compile the code. Next, we are going to upload the dataset. Let's create a new variable. I'm going to name it uploaded. You can name it whatever you want, and we are going to upload the dataset using files.upload functions. Just a quick reminder, we are going to get our datasets from Environmental Protection Agency website. So make sure that you've already downloaded the datasets from this website. Okay, let's go back to Google Colab. Let's compile the code. I'm going to click Choose Files. And here is the dataset that we are going to use. Let's click Open. Okay, so now it is uploading the dataset. It might take a few seconds. Okay, as you guys can see, we have successfully uploaded the datasets. Next, we are going to load the dataset using pandas. Let's create a new variable. I'm going to name it data. You can name it whatever you want. It is totally up to you. And in this case, we are going to use pd.read CSV functions. And let's copy and paste the file name, advis pivotal data CSV, and let's put it inside the parentheses and let's compile the code. Next, we are going to display the first few rows of the dataset. So let's type in data.head and let's compile the code. As you guys can see, this dataset has several columns. The first one is date, the second one is source. We also have site ID, POC, daily max, 3-hour carbon monoxide concentrations, units, daily AQI value. So AQI stands for air quality index. In this project, we are going to be mainly concentrating on this column, daily AQI value. Next, we also have local site name. So this is like the locations, daily ops count, percent complete, AQS parameter code, AQS parameter descriptions, method code, CBSA name, state FIPS code, state, county FIPS code, what else? County, site latitude, and site longitude. Just a quick reminder, guys, this data is from Los Angeles, California. So all locations in these datasets are around Los Angeles, California area. Okay, next, we are going to convert date column to datetime format and extract week number. You might be wondering why. Well, in this case, we are going to monitor a weekly air quality index for its locations. Okay, so we are going to extract data from this column, date. So let's copy and paste that and put it inside the bracket. And we are going to convert this column to datetime format using these functions, pd.toDatetime and we are going to put date inside this bracket. Okay, next, we are going to convert this column to week format. In this case, we are going to use dt.isSoCalendar.week. Okay, let's compile the code. Next, we are going to calculate weekly mean air quality index for its locations using npmeans. So make sure that you've already imported NumPy because we are going to use this library. Okay, let's create a new variable. I'm going to name it weekly mean AQI. You can name it whatever you want. It is totally up to you guys. Okay, we are going to use group by functions, data.groupby. So obviously in this case, we are going to group the data by the local site name, which is the locations, and also the week. So you can copy and paste this column. And put it inside the bracket. And also this column. And put it inside the bracket. We are going to add .ac. Okay, inside this parenthesis, we are going to have multiple things. Okay, firstly, we are going to get the first latitude value for each group. So I'm going to type in site latitude. And it is going to be first. Next, we are going to get the first longitude value for each group. Okay, let's type in site longitude. And it is going to be first. And lastly, we are going to calculate the mean air quality index value for each group. Daily AQI value. We are going to use lambda, x, and np.mean. So that's NumPy functions that you are going to use to calculate the weekly average. And we are also going to add .resetIndex to get a tidy data frame. Next, we are going to display the weekly mean air quality index value per locations. Okay, I'm going to type in weekly mean air quality index value per locations. So this is going to be the header. Next, we are going to create for loop to iterate through each unique locations. For your information, there are multiple locations in this dataset. for location in weekly mean AQI, so you can copy and paste this variable. And we want to find the unique locations, right? So let's copy and paste this column name, local site name, put it inside the bracket, and we are going to add .unique. Inside this for loop, we are going to filter data for the location. So let's create a new variable. I'm going to name it location data. You can name it whatever you want. It is totally up to you. And we are going to reuse the weekly mean AQI. Let's copy and paste the local site name, put it inside this bracket, equals to locations. Let's copy and paste this. Next, we are going to print the location name. So let's copy and paste the locations and put it here. After that, we are going to create another for loop to iterate through each row for the locations. For index, comma row, in location data, so you can copy and paste this variable, dot iter rows, inside this for loop, we are going to print the week number and average air quality index value. Okay, we are going to put week inside this bracket, so you can copy and paste this and put it here. Next, we are also going to print the average AQI value. We are going to copy and paste the daily AQI value. So copy and paste this and put it inside the bracket. Lastly, to get better output when we print this data, we are going to add new line. Before compiling the code, there are a few mistakes that we need to fix, so I really apologize for these mistakes. So this is the first one. This is supposed to be latitude. And this is the second one. This is supposed to be longitude. Okay, so now let's compile the code. Okay, here is the output. Let's rate this output. Weekly mean air quality index value per location. So the first location is Compton. The average AQI value for the first week is 12.71. In the second week, the average AQI value for Compton is 15.4. And for the third week, the average AQI value for Compton is 12.4. Okay, so let's pick another locations. Glendora. The average AQI value for the first week in Glendora is 2.8. The average AQI value for the second week in Glendora is 3.1. Okay guys, I think that's it. That's all you need to know. I'll see you guys in the next video.